Good day, ladies and gentlemen. This is MTS 102. The course title is Introductory Mathematics 2. Today we're moving into study section 5. Study section 5. It is Basic Principle of Integration. Basic Principle of Integration. Here we have the objectives of the section. That is, by the time you might have studied this section completed, you should be able to explain basic principle of integration, and also solve some examples on integration as summation, integration as anti-differentiation, and definite and indefinite integrals. Here we have the contents. As we have mentioned there, we have integration as summation, integration as anti-differentiation, definite and indefinite integrals. These are the contents we are going to be looking into one after the other. Here we have the introduction. Here. Integration can be regarded as a process of adding up, that is, as a summation. Whenever we wish to find areas under curves, volumes, etc., we can do this by finding the area or volume of a small portion and then summing over the whole region of interest. The calculation can then be performed using the technique of definite or indefinite integration. Here we have the learning outcome. By the end of studying this unit or this section, you should be able to explain basic principle of integration as mentioned before, and also solve some example on integration as summation, integration as anti-differentiation, and definite and indefinite integrals. Let's go on. Now, here we also have the definition here under the integration as summation. So as we have explained before, here we just want you to see how we represent integration as summation. This illustration here describe what we talking about. That is what we mean by integration as a summation. At the left hand side there, we have the integral from a to b, that is the limit from a to b, f of x dx. That is the integration part. And the summation part now, at the right hand side, we have it as the limit uh, as delta s approaches 0, summation s equal to a to b f of x dx. That is the summation aspect of it. So that is how to have it as a integration as summation. We have the integration part one side, we have the summation part the other side. So that is the integration as a summation. Let's move on. Here we have the practical example of what we are talking about. Number one, we have the summation here, where we have the limit, that is delta s tends to 0, summation s equal to 1 to 6. That is, we have it from where the limit is from 1 to 6, and the function given 4s raised to power 3 the s. That is the summation part, and that is to look into it as integrating part. Now integration part of it, we have it as integral from 1 to 6 4s raised to power 3 ds. So if you want to have it as an integration as summation, this is how it is being written. And we have number 2 also as another example. So this is the practical examples on integration and submission. Now, integration as anti-differentiation. Excuse me. Integration as anti-differentiation. We are going to look into this from this example where we have given the function y equal to 4x squared plus 5x plus 7. From our knowledge of differentiation, we proceed as follow. That is the y over the s, which is changing y all over changing s, is equal to the y over the s of 4x squared plus 5x plus 7. So the function of y given is 4x squared plus 5x plus 7. That is the function we are going to differentiate now. So by the time we differentiate this, we have the derivatives as 8x plus 5. I believe every one of you can differentiate this function easily. If we differentiate 4x squared, it gives us what? 8x. If we differentiate 5x, we have 5. And 7 is a constant, it is 0 by the time we're differentiating it. So that is the derivative there. So we now want to have it integrate. So if we turn around to integrate, we have the y equal to 8x plus 5 in bracket the s. How do we go about that? So you just make sure that you cross multiply the derivatives you're having there, then you make the y the subject of formula, then we have it as the y equal to 8x plus 5 in bracket the s. So now take the integral of both sides, take the integral of it. We have integral dy equal to integral 8x plus 5 ds. Now let's now integrate. If we integrate dy, it's just as if we are having it as 1 dy. So if we integrate it, we have, because we are integrating with respect to y here, then you have it as y. Then if we are integrating the other side, which is where we have integral 8x plus 5 ds, so we are integrating with respect to SA, so we now have it as 8x squared all over 2 plus 5x raised to the power 1 all over 1. How do we go about it? If you are integrating 8s, you know the power of s here is 1. So you add 1 to that power. If you add 1 to that power of s, it becomes 2. So if you are integrating, you always add 1 to the power, and the answer you are the power of s you are having, you divide it through by the whole base value you have in there. So we now have it as 8s squared all over 2. Then if we are integrating 5, you know 5 here is a constant. So it is like you are having it as 5s raised to the power of 0. If you have 5s raised to the power 0, it is 5. So the s raised to the power 0 you are having there, you now add 1 to it. The power of s is 0. Then let's add 1 to it. By the time we are integrating, it becomes 5s raised to the power of 1. Then you divide through by the power, which is 5s raised to the power 1 all over 1. So we now solve this. We have it as 4s squared plus 5s. So that is the answer. The answer we got there is y equal to 4s squared plus 5s. Now from the results, we see that we have a function looking almost like the initial function. You know the initial function given is y equal to 4s squared plus 5s plus 7. That is the initial function given. And looking at the result of the integration, you see that we have it as y equal to 4s squared plus 5s. They almost look alike, and that is why we are having it as a integration as anti-differentiation. So it is obvious that integration is a process of anti-differentiation. So from this now, I think it has validated the arguments there. So we move on to the next slide, where we have definite and indefinite integrals. Definite and indefinite integrals. An integral is the result of integration. An integral is the result of integration, while an integrand is the function to be integrated. So an integral is the result of integration. That is, the function you integrated, the value you get from there is, we call it an integral. That is the result we got from the integration. So why an integral is the function to be integrated. That function given to be integrated, we call it an integrand. So the result of a definite integral is usually a numerical value. It's usually a numerical value, while the result of an indefinite integral is a function with an arbitrary or actual constant. So as the case may be, let's now look into this expression where we have a definite integral can be expressed as integral from a to b f of s dx is equal to f of b minus f of a. So the limit, that is from a to b. So by the time we integrate it, we now have the limits substituted, and we have it as equal to f of b minus f of a. So when by the time we get to the practical example, then you understand more about it, where f of a and f of b are the values of the integral of f of s evaluated at the integral limit a and b. So an indefinite integral can be expressed as integral f of s dx equal to f of s plus c. So here we have the constant introduced with the function we got. So where f of s is the integrand, f of s is the integrand, that is the function to be integrated, while the capital F of s is the integral and c is the arbitrary constant. That is, the result we got is the integral here, that is the capital F of s, and then we introduce the arbitrary constant with it. So example on indefinite integral now. Examples on indefinite integral. We are looking into it one after the other. First of all, check the number one. We are to integrate s dx. Number one, integrate s dx. So how do we go about this? The function given is x. That is, what's the power of s here is 1. So by the time you are integrating, you add 1 to that power and it becomes 2. Then you now divide through by that power. That is why we're having it as s squared all over 2. Then with the introduction of a arbitrary constant. So the answer is now s squared all over 2 plus c. That is on number one. Then we move to number two. We are to integrate 3s squared plus 2s minus 1 dx. 3s squared plus 2s minus 1 dx, which is equal to s raised to power 3 plus s squared minus s plus c. So if you want to integrate 3s squared, you know the power of s there is 2. Then you add 1 to it, making 3s raised to power 3 divided by that power. That is 3s raised to power 3 divided by 3. Then the 3 will cancel, the 3 at the denominator we cancel out, and we are left with s raised to power 3. Then if we are integrating 2s, it is 2s raised to power 1 plus 1 all over 1 plus 1. So we have it as 2s squared all over 2. So the 2 will cancel out and we are left with s squared. And also, if we are integrating 1, you know 1 is a constant, and it is like you are having it as 1s raised to power 0. You know 1s raised to power 0 is still 1. So you now add 1 to that power of s there, which is 0. It becomes 1s raised to power 1 all over 1. Then the answer will become s. That is, we now have it as s raised to power 3 plus s square minus s plus the arbitrary constant, which is c. Then we move to number 3. Number 3, we have a integral cos s ds. If you are integrating cos s ds is equal to sin s. You know, if we are integrating cos s, it gives us what? Sin s. Then you introduce the arbitrary constant. Here we can also see it as excuse me. We can also see it as a anti-differentiation, integration as anti-differentiation. You know, by the time we're differentiating cos s, it is minus sin s, and if we integrate now, it gives us sin s. So this is the integral of cos s. We have it as sin s and with the arbitrary constant. Now we move on to examples on definite integral. Examples on definite integral. Here we have number 1 as integral from -2 to 1 the s ds. Integral -2 to 1 s ds. You know, the limit is given here from -2 to 1. So here we are integrating s. We're integrating s ds, and when we are integrating s, the power there is 1. We add 1 to it, it becomes s raised to power 2, then divided by that power, which is 2. So it becomes s squared all over 2 with the arbitrary constant. So here we now introduce the limits. We introduce the limit is from -2 to 1. So you now begin to substitute the limits one after the other. So we are starting from 1. So substitute 1 where you see s. Anywhere you see s, represent it with 1. Then we have it as 1 square all over 2. So minus, you know, it is 1 square all over 2 plus c. Then we now substitute the value of -2 again. We have it as, then you put the sign of minus, you now have it as -2 square all over 2 plus c. By the time you open the other one brackets, by the time we open the bracket, you know the c will cancel out. That c, the arbitrary constant, will cancel out, and we are left with 1 over 2 minus 4 over 2. So the answer we got here is equal to -3 over 2. -3 over 2. So that is that. You can see that this is the practical example on definite integral. And also number 2, we have it as integral from 0 to 2, that is the limit, into s square plus 1 ds. That is, we are to integrate s square plus 1 ds, and the limit is given from 0 to 2. So how do we go about it? S square, the power there is 2. We add 1 to it, it becomes 3. Then divided by the power, we now have it as s raised to power 3 all over 3 plus, we are integrating 1 again. That is, that constant is like we're having it as 1 s raised to power 0. You know, I've explained that any variable raised to power 0 is still 1. So we now have it as 1 s raised to power 0 plus 1. You add 1 to that power, then you divide it through by the value of that power there. Then we have it as x. So taking the limits, we now substitute the limits one after the other. Then substitute 2 where you see s. We now have it as 2 raised to power 3 all over 3. And 2 raised to power 3 becomes 8 over 3. Then plus, if you plus 2, that is s, you should also substitute 2 where you see s, then plus 2, then close the bracket, minus, now we have 0. Let's substitute where we have 0 to where we have s. Substitute 0, we now have it as 0 raised to power 3 all over 3, and it becomes 0. Everything there becomes 0. So we now have our answer as 14 all over 3. 14 all over 3. That is the answer to question number 2. Then we now move on to number 3. Number 3, we have integral from 0 to pi sine s ds. Integral from 0 to pi sine s ds. How do we go about this? If we are integrating sine s, we have it as what? Minus cos s. If we are integrating sine s, it gives us minus cos s. So here we are taking the limit now from 0 to pi. So we have gotten our in the integral as a minus cos s. So let's now introduce the limit. The limit given. We first of all introduce pi. Where we see s, put pi, substitute pi there, then cos pi will give us what? You know pi is 180. Pi is 180, and we now have it as cos 180. So what is cos 180? So the answer is what? Minus 1. So you know minus outside here into that bracket minus 1. So it becomes positive. So also minus, you now substitute 0 again. You substitute 0 to where you see x. So if you substitute 0, we now have it as cos 0. And what is cos 0? We have 1. Cos 0 will give us 1. That is why we're having it as the first one gave us minus into minus 1 plus, then cos 0 give us 1. So cos pi is the one that give us a minus 1, while cos 0 give us 1. So by the time we add it together, we have answer to be equal to 2. The answer is equal to 2. So that is the how to go about the definite integral. Those are the examples there. Those examples has explained what you meant by definite integral. So you can see that in definite integral, you know, that arbitrary constant will always be there. But when it comes to definite integral, you know, we have the arbitrary constant already cancelled out, and we have the real values there. So you can see the difference between them now. And I believe this, as we have come to the end of the class for today, and by the grace of God, we're moving to another one next time we meet. Thank you for listening. Bye for now.